Okay guys, so we've learned all about the formula, we know how to use the binomial formula, so now we're just going to go through some examples of what could be asked of you. So you can see the first question here says to find the coefficient of x to the power of 7 in the expansion this. Okay, no problem. So we know from Pascal's triangle, etc., that a here is 4 and b is minus a half x, right? So if we're trying to find the coefficient of x to the 7, we can use our theory of combinations, can't we? So our n is 9, c, and our r is 7, so 7. We would have a to the power of 9 minus 7 times b to the power of 7. Okay, so this will be n choose 7 times a, which is 4 to the power of 2, times b, which is minus a half x, all to the power of 7. Okay, so let's expand that. So we would get, if I type in a calculator, n choose 7, I get 36. And then 4 squared is obviously 16. And then minus a half x all to the power of 7, so minus 0.5 to the power of 7 equals minus 1 over 128 all times x to the power of 7. So if we're talking about the coefficient, we're just talking about the numbers next to the term of x to the 7. So never give the x in the actual answer. Your final answer needs to be this stuff all here, okay? So my final answer is going to be 36 times 16 times minus 1 over 128. So let's type that in a calculator, and we get minus 9 over 2. So the coefficient equals minus 9 over 2, okay? Answer done. So easy, isn't it? So much easier than drawing out all this Pascal's triangle and all this stuff. Okay, then the question's saying expand this expansion up to the term x cubed. Okay, thank you kindly. So this isn't in the form 1 plus something, so we need to get it in the form 1 plus something. So I will take out the 4. It's to the power of 9, so 4 to the power of 9. Divide the inside of the bracket by 4 then, so I get 1 minus 1 over 8x all to the power of 9, isn't it? Yeah? So, this means then we expand as normal, so equals 4 to the power of 9, leave that all the way to the very end. It's only asking us up to the term x cubed, so I have my 1 plus my n is 9, times minus 1 over 8x plus 9 n minus 1, 8, all over 2 factorial times minus 1 over 8x all squared plus 9, 8, 7, 3 factorial minus 1 over 8x all cubed plus dot dot dot. Yeah? Close your big bracket. Because I don't care about stuff beyond x cubed, that's not what the question's asking for. So let's get this. This is 4 to the power of 9, big bracket, 1 minus 9 over 8x plus 9 times 8 divided by 2 is 36 times minus 1 over 8 all squared is 9 over 16 x squared. This is a minus cubed, isn't it? So it's going to give me a minus number. Okay, always look for things that make sense. So 9 times 8 times 7 divided by 3 factorial all times minus 1 over 8 cubed is minus 21 over 128 x cubed plus dot dot dot. Don't care about the rest. So then my final answer will be, once I've multiplied out the brackets, so I get 4 minus a half x to the power of 9 is approximately equal to, because I'm only given the first 3 terms, so I'm going to multiply all this bracket out by this 4 to the power of 9. So 4 to the power of 9 is, wow, that's a big number, is 262,144. Okay, minus that answer times minus 9 over 8 x, so times 9 divided by 8, I get 2294912 x plus 4 to the power of 9 times 9 over 16 this time, 147,456 x squared minus 4 to the power of 9 times minus 21 divided by 128 is minus 43008 x cubed plus dot dot dot. And there we go, we've done it. Now a really cool use of binomial, and actually what binomial was, I suppose, used for in the first place, was in order for us to kind of like approximate numbers. So if someone asked you to work out, well, what's 0.999 to the power of 7 in your head, you would be like, what the fudge? Yeah? You ain't going to answer that, are you? But we can use binomial to do that, okay? So a question could say, find 0.99 to the power of 3. Okay, this is just a simple example. Now I could, before calculators were invented maybe, we could use binomial expansion to work this out. How I could do it is, I could say, okay, what's 1 plus x, which is our binomial expansion formula, isn't it? In the form we need, 1 plus x to the power of 3, what's that equal to? And then I could make my x here the difference that would make this. So if I had 1 minus 0.01 cubed, then I would make my x equal minus 0.01 here, wouldn't I? Right? So let's do this. Let's first expand this up, and you'll see what I'm talking about. So 1 plus x cubed equals, from our formula, 1 plus n is 3, x plus n is 3, n minus 1 is 2 factorial, x squared plus 3, 2, 1, 3 factorial, let's put this down here, 3, 2, 1 over 3 factorial x cubed. Remember, that is 3 factorial, so that whole thing is going to be 1. So if we simplify this, we get 1 plus 3x plus 3x squared plus x cubed. Okay? Brilliant. So 1 plus x cubed equals this. Now, we can do what I said we were going to do. We're going to make, so we're going to let x equal minus 0.01. So that way I can say 1 minus 0.01 cubed is the same as 1, which is here, plus 3 times my x is minus 0.01, which is here, plus 3 times minus 0.01 all squared, which is here, and then finally plus my x 0.01 all cubed equals 1 minus 0.03 plus minus 0.01 all squared times by 3 will give you 0.0003 minus 0.01 all cubed 0.00001. Yeah? So this means then, for our final answer, because of course 1 minus 0.01 is what we were looking for, 0.99 cubed, equals 1 minus 0.03 plus all this, blah, 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 blah. Okay? Do all that. This will equal, well, 1 minus this whole thing will give me 0.999999. Still got this remaining, minus 0.03 plus 0.0003. So remember, this is without a calculator. Okay? So then I'm doing 0.99999 minus this. This will give me 0.969999. Still got this plus 0.003 at the end. And then finally I just have to plus this 3 on. So I get my final answer, 0.9 plus on this, so this is going to be 9, 9. This will become 2, this will be 0, this will be 7. And there's my final answer, okay? Because if I type this into a calculator, I will get exactly 0.970299. So do you see how binomial expansion can be used to solve number problems like this? The trick is, the hard bit is knowing what to make your x, okay?